Good morning, viewers. Welcome to my YouTube channel, The Diligent Coaching Seminary. This is an academic YouTube channel for you in which I upload several tutorial videos related to the courses of the schools and colleges. And I want all the students to watch my videos and get benefited for your study. And before to start my today's lecture, I want to request all the viewers and students, please kindly subscribe my channels and press the bell icon such that whenever I bring new tutorial for you, you will get the notification and you can watch my upcoming new videos easily. And I also want to request all the viewers, please like my videos and share and comments such that I will get inspiration and encouragement to bring new online coaching videos for you and I can benefit you. And I also want to request the students, if you want a lecture on particular topic of the particular subject of the particular class, you can mention that in the comment box, and from there I will bring your required video for you. In my previous videos, I have given you the lecture for the class 10 students in the subject of science, and there I have given you the lectures of the chapter 4, which is the first chapter of the physics, and I have already given you the 3-part video of the chapter 4, and this is the part 4 of the 4th chapter of the class 10 science book. And in my previous video I have explained about the gravitational force and Newton's law of gravitation and formula of the gravitational force, universal gravitational constant, and effects of the gravitational force and all. And if you haven't watched my previous video, I recommend you to watch my previous video, which is based on the gravitational force and the Newton's law of gravitation. And this is the 4th part for the 4th chapter of class 10 science book. And today I am going to discuss about the gravity. So let's start the today's lesson. First of all, you have to know the definition of the gravity. So first of all, let's see what is the definition of gravity. So I think you can see the definition in the screen as well. The force by which the earth attracts every object towards its center is known as the gravity. So the force by which the earth attracts every object towards its center is known as the gravity. And gravity is also called the force of gravity. So force of gravity and simply gravity is same. And when any object is thrown upward, then it returns downward, and it is because the earth is attracting every object towards its center. That is the reason the object cannot escape away from the surface of the earth. So this is the reason of the presence of gravity, and the kind of force by which the earth attracts every object towards its center is known as the gravity. And the one example of the gravity I have already said you, when any object is thrown upward, it returns downward. And now let's see the formula to calculate the gravity. Gravity is also one kind of force of attraction, like gravitational force. That is the reason the formula of the gravity is similar to the formula of the gravitational force. And the formula of the gravitational force you have already studied in my previous video. That is F equals to G m1 into m2 by d square. Now here the formula of the gravity is nearly same to the formula of the gravitational force. Here the formula I have mentioned here, F equals to G capital M small m upon r square. And here capital M is the mass of the planet, small m is the mass of the object, and r is the radius of the planet. Now, why this type of formula is used for gravity is, the formula of the gravitational force is G m1 into m2 by d square. Now m1 means mass of the first object, and in the case of gravity, mass of first object means the first object is the planet. So planet like earth. So mass of the planet is the first mass of the first object, and second object is obviously any object which is located at the surface of the planet. So capital M is the mass of the planet, which is m1, and small m is the mass of the object, which is m2. And you know, the object has negligible weight in comparison to the planet. That is the reason the formula we have obtained here, F equals to G capital M small m upon r square. So here m is the mass of the planet, small m is the mass of the object, and r is the radius of the object. I think you have understood the formula of the gravity. So this formula should be used to calculate the gravity. And now SI unit of the gravity is obviously Newton, because gravity is also one kind of force, and Newton is SI unit for every kind of force. So that is the reason Newton is SI unit of gravity as well. And whenever you calculate gravity in the numerical question, you have to write the unit Newton. And gravity depends upon two factors, and it is known from the formula. Once again, let's see the formula of the gravity. The formula of the gravity is G capital M small m upon r square. Then whatever quantities are here in the formula, the gravity depends upon same quantity. And here we have mass of the planet capital M and radius of the planet as r. That is the reason gravity exactly depends upon these two factors. And that is, one factor it depends upon is mass of the planet, and another factor it depends upon is radius of the planet. So gravity depends upon these two quantities, these two factors. So these are the two factors which are affecting the gravity. Now gravity not only depends upon only these two factors, but it may depends upon the mass of the object as well. Now here we are going to discuss the effects of the gravity. What kind of effects are caused due to the gravity of the earth? First of all, tides occur in the sea or ocean due to the effect of the gravity. Tides is defined as the phenomenon by which water level rises in the sea or ocean. And water level rises in the sea or ocean because of the gravity of the moon. The gravity of the moon acts on the water of the sea or ocean. That is the reason the water of the sea or ocean is attracted towards the moon. It cannot escape away due to the gravity of the earth, but the moon tries to draw the water level up in the sea or ocean. So it is the one effect that the tides occur in the sea or ocean due to the effect of the gravity of the moon. And now the presence of the atmosphere is also effect of the gravity. If gravity is not present in the earth in enough magnitude, then atmosphere cannot stay around the surface of the earth. The atmosphere is present around the outer surface of the earth. It is due to the gravity of the earth. The gravity is holding the atmosphere around the outer surface of the earth. And another effect of the gravity is water flows in downward direction. It is also due to the gravity. If gravity is not present in the earth, then water does not flow in downward direction. And another effect of the gravity is when any object is thrown upward, it returns downward. It is also due to the pull of the gravity of the earth. So these are the effects of the gravity that we are seeing in our daily life. And now what are the factors affecting gravity? Let's see detailedly. That means what kind of effect is there by those factors. In the previous question we have already seen the gravity depends upon two factors, that is mass of the planet and radius of the planet. First of all, gravity is directly proportional to the mass of the planet. The meaning of the directly proportional to the mass of the planet is when mass of the planet is more, the gravity is more, and the mass of the planet is less, then gravity is less. So gravity is directly proportional to the mass of the planet, and it is written as F This is the sign of proportional, F proportional to m. Then second affecting factor is radius of the planet, and you have already seen in the formula that the gravity is inversely proportional to the square of the radius of the planet, and it is written as F proportional 1 by r square. And in my previous video I have already said you, whenever you see this inversely proportional in the statement, then you have to write 1 by. That means inversely proportional to something means 1 by something, and proportional sign is same. So F proportional 1 by r square means the gravitational force is inversely proportional to the square of the radius, and it means when radius of the planet is more, then the gravity is less. Here is opposite effect, and when radius of the planet is less, then gravity is more. So inversely proportional means the relation is inverse or the relation is opposite. So these are two factors which are affecting gravity, and one is directly proportional, that is mass of the planet, and another factor is inversely proportional, that is radius of the planet. So now let's see the reasoning fact. The mass of the Jupiter is 319 times more than that of the Earth. And I have already said you, when mass of the planet is more, then gravity is more, and when mass of the planet is less, then gravity is less. Then since mass of the Jupiter is 319 times more than mass of the Earth, then gravity of the Jupiter also should be 319 times more than gravity of the Earth. But the gravity of the Jupiter is only 2.5 times more than the gravity of the Earth. Why? The reason behind this fact is, yes, gravity depends upon the mass. Gravity is directly proportional to the mass of the planet, and when mass of the planet is more, gravity is more, and when mass of the planet is less, gravity is less. So since mass of the Jupiter is 319 times more than that of the Earth, then the gravity of the Jupiter also should be definitely 319 times more than that of the Earth. The reason is since F proportional to m. But the gravity not only depends upon the mass of the planet, but it also depends upon the radius of the planet as well. And the dependence of the gravity with the radius is the inverse relation, That means the gravity of the planet is inversely proportional to the radius of the planet. That means whenever radius is more, gravity is less, and whenever radius is less, gravity is more. Here is the inverse relation. And inverse relation of the gravity not with the radius, but it is with the square of the radius. That means gravity is inversely proportional to the square of the radius. That is the reason when the radius is more, then gravity should be less, and the radius of the Jupiter is also 11 times more than that of the Earth. And when radius is more than that of the Earth in the Jupiter, then it causes the decrease in gravity. That means it causes the less gravity in the Jupiter when radius is more in the Jupiter. So since radius is 11 times more in the Jupiter, the gravity of the Jupiter should decrease by 11 square time, because the force of gravity is inversely proportional to the square of the radius. It is not inversely proportional to the radius, it is inversely proportional to the square of the radius. So it is decreased by 11 square time, and that is 11 square is 121. And that is the reason what you have to know is because mass is 319 times more in the Jupiter, the gravity of the Jupiter should be increased by 319 times in the Jupiter. But since the radius of the Jupiter is also 11 times more than the radius of the Earth, it decreases the gravity of the Jupiter by 11 square time, that is 121 times. So here mass is increasing the Jupiter gravity by 319 times, and radius is decreasing the gravity by 121 times, and in aggregate it will be 319 upon 121, and it will be 2.6. But since it is being decreased by 121 times and it is being increased by 319 times, that means increase is more than decrease. Increasing by 319 times, decreasing by 121 times. So increase is more. That is the reason gravity is more in the Jupiter. But the amount by which it is more is 319 upon 121, and it is 2.6, and approximately it is 2.5. That is the reason gravity of the Jupiter is only 2.5 times more than that of the Earth. So only one thing you have to understand, because mass is 319 times more in the Jupiter, gravity of the Jupiter also should be 319 times more. Because of this relation, it is directly proportional to the mass. But radius of the Jupiter is also 11 times more than that of the Earth, and which causes the decrease in gravity by 11 square time. It is because the gravity is inversely proportional to the square of the radius. So it is increased by 319 times by mass, but it is decreased by 121 times by the radius, and aggregate increase is 319 upon 121, which is 2.6, and it is approximately 2.5 times more than that of the Earth. So this is the reason that Jupiter is very larger in comparison to the Earth, but its gravity is just 2.5 times more than that of the Earth. I think you have understood. Now let's discuss about the gravity of the moon. And you know, mass of the moon is less than that of the Earth, and radius of the moon is also less than that of the Earth. Now let's discuss one hypothetical question. Suppose the Earth is squeezed to the size of the moon. That means it is compressed to the size of the moon. Then what will happen to the gravity? And obviously, you know, when the Earth is squeezed to the size of the moon, then its mass won't change, is it or not? Its mass remains same whenever anything is squeezed. Only one change will be the change in radius. So whenever Earth is squeezed to the size of the moon, then you definitely radius is decreased. It is clear, because radius of the moon is less than radius of the Earth. So Earth is squeezed to the size of the moon means the radius of the Earth is decreased there. Then it is made equal to the radius of the moon. Then whenever radius is decreased, then the gravity will increase, because the relation, you know, the gravity is inversely proportional to the square of the radius. That is the reason here definitely the gravity of the Earth will be increased, and it is increased by 14 times, because whenever Earth is squeezed to the size of the moon, then radius will decrease there. Now let's discuss the differences between gravity and gravitation. First of all, you have to know gravity and gravitation are similar kind of force. The similarity between them is the basic is similar. Gravitation is force of attraction, and gravity is also definitely force of attraction, because a definition has said that. But there are some differences between gravity and gravitation is there. Let's discuss the differences between gravity and gravitation. And first of all, the definition is different. Gravitation is defined as the mutual force of attraction between any two objects in the universe is known as the gravitation. But the definition of gravity we have already discussed. The force by which the Earth attracts every object towards its center is known as the gravity. Gravitation is the universal force, but gravity is not an universal force. Okay? Then the gravitation exists between any two objects in the universe. Like gravitation is present between desk and bench of your classroom. I have already said you. The gravitation is present between book and copy. Gravitation is present between two buildings of your neighbors. Gravitation is present between your body and the body of your friends, like this. But gravity is slightly different, and it exists between a planet or satellite and the object located in its gravitational field. That means for gravity there should not be any two objects. For gravity, one object should be either planet or satellite, and another object should be any object located in the gravitational field of that planet or satellite. That means let's take the example. The force of attraction between two houses, it is the gravitational force, gravitation. Force of attraction between your pen and pencil, that is gravitation. Force of attraction between two stones, that is gravitation. But force of attraction by the earth in any object, that is the gravity. So these are the main differences between gravitation and gravity. That is what I want to clarify here. So gravitation is the force of attraction which exists between any two objects. But gravity is also force of attraction, but it exists only in the specific case. That is, one object should be either planet or satellite, and another object should be any object located in its gravitational field. So these are the differences between gravitation and gravity. So students, I hope you have understood the concept of gravity properly, and I want to request all the students once again, please kindly subscribe my channel and press the bell icon such that whenever I bring other upcoming videos, then you will get the notification in the YouTubes. And I'll bring the remaining concept of this fourth chapter of class 10 science book in my upcoming videos. So for today I want to say goodbye, and all the viewers stay blessed. Thank you.